A software engineer. We have the internet on everybody's lips. We have URLs and paper advertising. I actually heard an interesting thing on NPR coming in this morning that by Kevin Phillips, who's a pundit, who said that we're actually, this election and what's going on in society right now is a battle between technology and oil. And Kevin Phillips, even though he's a conservative, said that technology is going to win. And certainly when people think of technology, they think of computers. But that wasn't true 50 years ago when computing began here at Carnegie Mellon. At that time, well, actually, I would date the moment computing began here at Carnegie Mellon, actually not as 1950, but 1952, when Herb Simon met Allen Newell, which actually happened at the Rand Corporation. That ignited a spark not only in computing, but at Carnegie Mellon and in many other intellectual fields, which is still burning brightly. But in any case, I think it was 1956 or 1954 or something, we got the first computer here at Carnegie Mellon, which was, I believe, a computer called a G15, which looked like a big gray refrigerator and had paper tape coming out of it. And that and many of its successors were these great behemoths of computers which took up a lot of space and a lot of air conditioning and took forever to program using punched cards and a variety of other artifices that are best forgotten. And it certainly didn't seem at that time that these devices were going to be something that was going to be driving technology and be the center of industry in the year 2000. But for many of us, especially for me and many of my colleagues who were here at Carnegie Mellon, Herb Simon and Allen Newell created the field of computer science. In fact, they were calling it something different long before it was called computer science. They brought their colleague Alan Perlis here, who was the first computer center director. And for a whole generation of us, they sort of tricked us into the proposition that not only were computers going to be an important thing and a great place to make your career, and they were, compared to the physics I was studying at the time, it certainly was easier. But not only were computers going to be important, but software is important. I didn't realize that fully until maybe 20 or 30 years later when I was meeting people from Europe and Russia where and Japan for that matter, Ed Feigenbaum reported on that eloquently one time, where it was still primarily a hardware-driven thing. Everyone thought that the profession was in hardware, but here at Carnegie Mellon, as far as I can tell, it was recognized immediately and early that software and the creation of software of all sorts, including artificial intelligence, was crucial. So 50 years ago or so, Herb and Allen Newell, or Herb and the two Allens, had what turned out to be a crystal clear view of the future, or at least not exactly how the future was going to turn out, but how important computers are going to be. In fact, Herb and Al, as you probably all know, this symposium has been partly provoked by the idea that we're dedicating Newell-Simon Hall today. Herb and Al did many and very important things for Carnegie Mellon in the intellectual life of the country. In my opinion, they revitalized business, or the study of business and business education at GSIA. If you recall, back in 1950, I think the dominant paradigm was probably the Harvard Business School case study method, which, although being very effective and a great way for people to meet their future fellow executives, was in fact more or less a recitation of war stories. Herb and many of his colleagues at GSIA, besides Alan, Lee Bach, Jim March, and so forth, in some sense showed that, yes, we really could run businesses in a rational way, using computers as an aid. And that one of the painful ways in which we revolutionized business education actually was having all these people like Lee Bach and Jim March and so forth go to Stanford Business School and other schools where they revolutionized those places after it had started here. In any case, thank heavens for Carnegie Mellon. Al and Herb stayed here for their careers and went on to invent the field of computer science, the field of artificial intelligence, along with their colleagues Minsky and McCarthy from MIT, and the field of cognitive psychology. In fact, I didn't know until maybe 10 years ago that this cognitive psychology thing was a new field, which was in many ways created here at Carnegie Mellon and is now being led by our world-class psychology department. So we actually have a magnificent 50 years to look back on. When Herb when Herbert first arrived here, he was a young Turk, but if any of you noticed, he has remained a young Turk, and he's still a young Turk today. And at the end of the day, when you'll hear his talk, I'm sure you'll agree with me. In any case, being a young Turk, I think he predicted sometime in the 50s. He and Al began the study of, first they did a thing called the logic theorist, and they did interesting ideas of using computers as symbolic calculators as opposed to numerical calculators. They invented the programming language IPL, which was eventually superseded by Lisp, which had slightly better human factors. But the original idea for all the things that we teach all of our students these days, push-down lists, linked lists, recursion, and so forth, really started with that IPL language. In any case, probably the most memorable thing, or one of the more memorable things Herb did in there, was to predict sometime in the middle 50s that in 10 years a computer will be the world chess champion. Lots of people didn't believe that. They especially didn't believe it 10 years later when it turned out not to be true. But I think the important thing that distinguished the kind of work Herb and Al were doing is they were not just prognosticators. In fact, their day job was to actually do it. So they were actually creating these many artificial intelligence programs and working on these problems full time. They just weren't sitting back and predicting when things would happen. And so they had a serious, I think, encouraged by other people like Oliver Selfridge and others, they had a major, serious crash program to create the world's greatest chess player on a computer. Even in the impressive thing, I was reminded by Mike Shamos a couple of years ago, in some sense, the signal that we meant business here at Carnegie Mellon was that we went out and hired a chess master, Hans Berliner, guy who had been the world correspondence chess champion, hired him and put him on the faculty and said, work on nothing but chess for the next 20 years. And so having a professor devoted entirely to the study of chess was a sign that we were very serious about our work and so on. So some amazing insights came out of this program. Actually, I think the most interesting thing that they used their methods from cognitive psychology, by the way, in working on this problem. And an interesting little fact they discovered was that a grandmaster chess player could look at a board for a few seconds and then reconstruct an entire chessboard without looking at it again. And as somebody who was merely a master or an expert would miss a few things, and most of us who looked at it for a few seconds wouldn't be able to do it. So they were studying this problem not so much as a let's create an artificial thing to do it, but as a human problem. And of course, as many of you know, that's been the hallmark of their work. In some sense, they were primarily trying to understand human beings and the nature of intelligence in all devices. And that's what's driven the artificial intelligence agenda here and what keeps it an exciting area. No matter how many chess masters we create or how many cool things we make here, the intellectual heart of this is an inquiry into intelligence. So anyway, the chess thing, well, from my point of view, the chess battle, in fact, was won in the first 10 years when a program written by Richard Greenblatt at MIT was able to beat me. I said, well, I also, by the way, beat one of the major critics of AI in those days, Herbert Dreyfus. So for me, I said, well, it might not be able to beat a chess master, but these computers are not all bad. But the chess thing obviously wasn't the key idea, the most important part of artificial intelligence. In some sense, it was an artificial activity, both for men and computers, because it was, my heavens, it's 9 o'clock. Got to rush along here. There are many other, in some sense, more difficult and more important problems in artificial intelligence, which Herb and Al and many of their colleagues worked on. Raj Reddy came here and took on the speech problem as his major thing, and he's been working on that for, I suppose, not 50 years, but 30 years. Takeo Kanade, who is probably one of the world's greatest experts in computer vision, has been here working for many, many years on how do you get computers to see. Jaime Carbonell, in a similar way, has dedicated his career to working on language. So we don't spend a lot of time simply predicting things here at Carnegie Mellon. We're really pushing this thing forward. And I would describe our brand of artificial intelligence, I would almost call it artificial intelligence engineering, in the sense that we work on these extremely hard problems, voice, vision, language, which take many, many years of dedicated effort. And that's sort of been the hallmark of the things we've done. Well, another postscript on this, not postscript, but when a computer finally beat the world's champion, it was done with a huge amount of hardware. And I think sometime in the 80s, Hans Berliner and many of his graduate students started saying, well, and encouraged by Allen Herb, said, let's just see if we can compute this problem to death. And in the end, what really made the thing work was a huge amount of cleverness by some of Hans's students who had since gone on to IBM, Murray Campbell and company, as well as huge amounts of power. So one of the things that sort of started to happen in the 70s is Moore's law started to get to be a serious thing. You know, Moore's law is the law that says that computing doubles in its capacity or its price performance every 18 months or so. It's not really a physical law. It's sort of a challenge by Gordon Moore to the industry and the Intel engineers. A striking comment made by, I think, both Bill Joy and Ray Kurzweil is the fact that this is an exponential process, and the fact that this doubles every 2 years means it's something that humans can barely comprehend, in the sense that every exponential process, essentially in its growth period, is an explosion. So what's now happening with computing is overwhelming. I think in some ways, was the centerpiece of, not centerpiece, but an important observation of Ray's book. When we've done these calculations to the effect that computers are going to exceed human intelligence or do something in the future, we now not only have the intelligence and brilliance of people like Herb and Raj Reddy and so forth working on this problem, we also have the hardware engineers performing these miracles of a doubling of computer capacity. So when you do your calculation of what's possible in the future, it's not, unfortunately, I think most of us humans are essentially linear devices, and we say, well, if it's been this way for a while, it'll continue this way. Our calculation or estimation of what's going to happen in the future is severely impeded by the fact that it's an exponential and we're more or less linear. So in any case, this is what we're going to try to do in this symposium today. Quickly speaking, I wanted the title for this symposium to be Artificial Intelligence. First it was a failure, now it's a success. Now it's a success, when will it be a menace? Because Bill Joy wrote a very provocative article about a year ago in Wired magazine saying, well, gee, folks, nanotechnology, biotechnology, and computer technology are really charging ahead, and maybe we better pause to think whether this is really going to be a good idea. Now, in fact, what was most noteworthy about this wasn't Bill's predictions, which I'm sure you could have found in many cases. It was the fact that Bill was a guy from the heart of the computer industry. He's the founder of Sun Microsystems, and so that took great notice, as it did when Joe Weizenbaum, an expert in artificial intelligence, about 25 years ago raised serious issues. So when one of the people from inside the club raises a warning, it gets attention. What provoked Bill were a number of things, including two quite wonderful books by Hans Moravec and Ray Kurzweil, who were here today to talk to us. And I'm sure at the end of the day we are going to conclude that we should start making progress, or we'll continue to make progress. By the way, there's some evolutionary evidence that human beings are by nature optimistic, in the sense that we constantly overestimate the goodness of the future, and that's good. That's a good evolutionary principle. Or as a friend of mine said, if you ever really calculated how difficult something was going to be and what the consequences were, you would never actually do it. So anyway, humans will keep charging forward no matter what this symposium says, and it will be totally, furthermore, there's no hope that we will accurately predict what the future is, but I think it's very important as computer scientists, as just thinking people, that we understand in a deep way the products of our science. So that's what this symposium is about. It's not so much to celebrate the glories of the past, although there have been many of those. It's to try to understand the future. As you'll see, I'm not going to read the program out since I'm running out of time, but as you'll see, if you are a cognoscendi in this area, you'll see that we've sort of loaded the agenda with people who might be on both sides of this question. I wouldn't quite say they sort of alternate. By the way, Bill Joy can't actually be here physically, but we're going to experiment with a new technology called synthetic interviews, and where you will be able to talk to a computer, which will try to do a reasonable job of simulating Bill. Let's see. Before I introduce Ray, a few other announcements. There's as you probably know, the dedication of the building is at 5 o'clock, and I hope you'll all come and hear that. I'd like to thank Raul Valdez Perez. Are you here, Raul? Raul is a distinguished artificial intelligence researcher who's actually pioneered an area involving the use of artificial intelligence in scientific thinking. He's the person who selflessly and energetically organized this symposium. And his partner in crime is Catherine Capitas, who did all the local arrangements. Are you here, Catherine? Catherine's out at the desk handing you your badges. So I think I'd like to thank both of these people a lot. So now it's my pleasure to